with YouTube. So please wait for 1 minute. Okay, good afternoon, ladies and gentlemen, all the participants today. Today we will have a talk from two experts from our colleagues in University of Australian National University and then the Peking University. I would like to greet our honorable speaker today, Dr. Hsiao-chun and Dr. Zhenhua. Welcome to our talk show today. We hope that you will give a lot of knowledge, a lot of information today regarding the historical background of rice and millet cultivation in Southeast Asia and also in East Asia. And today, before we begin our talk show, we will have some short introduction from the head of Center for Prehistory and Austronesian Studies, Professor Truman Simanjuntak. Professor Truman Simanjuntak, good afternoon, Prof.
Good afternoon.
Good afternoon, selamat sore, Prof. Mungkin bisa untuk audiens kita yang di Indonesia, kita bisa mendapatkan sedikit introduksi, Prof, dari apa yang akan kita diskusikan pada sore hari ini. Silakan, Prof.
Oke, terima kasih. Selamat sore. Good evening, colleagues, ladies and gentlemen. Welcome to the talk show hosted by the CPAS, Center for Prehistory and Austronesian Studies. Thank you all for taking the time to join this webinar. Terima kasih hadir semuanya di dalam forum ini dan mudah-mudahan berhasil dan memberikan pencerahan nantinya lewat topik yang dibicarakan. So to remind that the Center of Prehistory and Austronesian Studies holds monthly webinars discussing actual and hot issues in the field of archaeology, especially prehistory, in order to bring the values of the past to the present. And we are so very happy that the discussions so far have received great attention from intellectuals and observers. And our talk show this evening will discuss the early domestication of rice and millet in connection with the Austronesian expansion. I think this is an interesting and even an everlasting issue, considering that this kind of plant is the staple food in a very, very large area, including in Indonesia. Imagine rice is a staple food for 1/3 human population in the world. 1/3 penduduk dunia makan nasi dan menjadikannya sebagai bahan makanan pokok, bukan main. So very, very what do you call that? Very important, this kind of plant for human. And it is already started from the past up to now. So for this, we are very happy to present two distinguished scholars as source persons. And they have experience in doing studies on plant domestication in different countries. I think most of you know them. Dr. Hsiao-chun Hung, this is my old friend, very, very active scholar and also very modest scholar. She is from the Australian National University in Canberra, and also Dr. Zhenhua-Deng from Peking University. Yeah, thank you very much, Hsiao-chun and Zhenhua, yeah, for your presence and contribution in this talk show. And this webinar coincides with the celebration of Indonesia's 77th Independence Day, which fell on August 17th, just yesterday. And it is also a momentum to appreciate the government's achievement in rice self-sufficiency. Jadi Indonesia sekarang sudah bersuasembada pangan, ya, artinya swasembada padi. Ya. So just some days ago, if you follow the news, ya, our president received an award from the IRRE, the International Rice Research Institute. Yeah, yeah, it's very interesting for this achievement. So this talk show welcomes those events, as of course will provide insight into the domestication of rice and millet, which began thousands of years ago and continues to be a staple of food nowadays. Yeah. So to all participants, take relax and wish you enjoy the discussion. Thank you very much. Okay, Rul. Ruli.
Terima kasih Prof. Terima kasih Prof. Truman atas introduksinya. Sehat-sehat selalu. Maaf saya tadi lupa mematikan mute-nya. Terima kasih banyak. Menarik sekali apa yang akan kita diskusikan pada sore hari ini, rekan-rekan sekalian, sahabat CPAS dimanapun Anda berada. Untuk mempersingkat waktu, saya akan memperkenalkan moderator pada diskusi kita pada hari ini, pada sore hari ini. Good afternoon, Mrs. Devi. So our today discussion, our today talk show will be hosted by Mrs. Devi as moderator. And she's a bright young researcher from the University of Airlangga as a cultural anthropologist, paleoanthropological, right? Or what should I say? Bioarchaeological.
Yeah.
Bioarchaeology. So Mrs. Devi, not to take more time for the discussion, so I will give the time and place for you to introduce our honorable speaker today. And saya juga akan menyapa untuk rekan-rekan yang ada di YouTube. Hello, all our followers in YouTube and our participant today. Thank you for joining us. Please enjoy the discussion. Silakan, Mrs. Devi.
Okay, thank you, Mr. Ruli. And good afternoon, everyone. Hello, nice to know you all. I'm Devi, and I'm very pleased to see you here. And welcome all of you to this public talk show, episode 5. Okay. And before we begin, I would like to introduce you to the speakers. And this is the first speaker is Dr. Hsiao-chun Hung from Australian National University. She is an archaeologist expertise in early Austronesian, maritime society, and ancient human migration. And she is currently involved in several archaeological research projects in China, Taiwan, the Philippines, Indonesia, Vietnam, Thailand, and the Marianas Islands. And her last paper was published on 2022, titled Before Rice, and the first rice, Arkeobotanical Study and How Long by Norton. Welcome to Dr. Hsiao-chun Hung. And the second speaker It will be Dr. Zhenhua-Deng. He is currently teaching at Peking University in China with expertise in ethnobotany, paleobiology, and archaeobotany. And his last paper on 2022 was titled Early Austronesian Cultivated Rice and Millet Together, Tracing Taiwan's First Neolithic Crop. Okay. And without further ado, I'd like to welcome our presenters to start the presentation. Please, Dr. Hsiao-chun Hung.
Okay. Can I share my screen?
Yes, please.
Can you see my screen now?
Very clear. It's good.
Okay, good.
Yes.
Okay. Good afternoon, everyone. I'm grateful for this opportunity to present our research findings about early farming in southern China, Taiwan, and the island Southeast Asia. Before presentation, I would like to thank the organizers, especially Professor Truman, who invited us to share the progress of our recent work. I will provide a brief summary of the project overall, and my colleague, Dr. Deng Zhenhua, will share details about the studies of ancient plant remains from several key sites.
Sorry, Dr. Hsiao-chun, it seems like you're accidentally muted. Yeah.
How about
okay.
now? Can you hear?
Yes.
Yes.
Okay.
Clear.
Sorry. So my first slide, could you hear my introduction in the beginning?
Yeah.
Yeah, okay. So this is the second slide. This is the beginning. As many of you already know, Austronesian was the most widespread language family in the world prior to AD 1500, representing one of the most impressive record of humankind's dispersal around the globe before the large-scale European expansion of the last few centuries. Today, Austronesian language was spoken by over 380 million people. These people live in area of Taiwan, the Philippines, Southern Vietnam, Malaysia, Indonesia, Madagascar, Melanesia, Micronesia, Polynesia, including New Zealand. As the Austronesian speaking population comprise the majority of the modern island Southeast Asia communities, their origin and homelands have been subjected to ongoing debates among scholars of a different field. Numbers models have been contradictory, and many have failed to refer to convincing evidence. The most influential and convincing model provided by linguists and archaeologists is the farming language dispersal hypothesis, aligned with the out of Taiwan model. The farming language dispersal hypothesis and the out of Taiwan model have been linked together concentrically. According to the farming language dispersal hypothesis, many of the world's major migration occurred by farmers seeking new lands for their crop and livelihood. And the farming population, in most cases, spoke unified languages. When people migrate, they brought their languages and other cultural traits with them. In East Asia, rice and millet were cultivated in central China about 9,000 years ago. In our early work, we identified two major directions of rice farming expansion from southern China to mainland Southeast Asia and to Taiwan, and then island Southeast Asia around 4,500 years ago. Before our recent intensive study in the Philippines and Indonesia, only 3 Neolithic sites in island Southeast Asia has shown evidence of rice and millet, and some of those findings lacked precise dates. As was mentioned, according to the farming language dispersal hypothesis, the Neolithic population movement in island South Asia most likely were motivated by people seeking new lands for their food-producing land use systems. However, as the direct evidence of farming was rather limited in island Southeast Asia, thus some researchers disagrees with the out of Taiwan model and the farming language dispersal hypothesis. Instead, they believe that the Southeast Asia islanders were hunter-gatherers for several thousand years until very recently. However, the major problem of the preservation of ancient plants in tropical Asia is poor, and the archaeobotanical work is too little in island Southeast Asia. As many of you might have been aware, rice and millet play a rather important role in the Austronesian societies today. Rice and millet are not only staple food. Today, they are important symbols for many festivals or special ceremonies in the Austronesian world. One major question is about the oldest dating of rice and the millet cultivation in Indonesia. For example, the famous Borobudur temple in Java depicts many stories related with the plants and the animals. Interestingly, rice and millet both were represented in the artwork at Borobudur. In Ian Glover's early work, he identified a possible millet from ᴊ𝘗𝘗 in East Timor around 3,800 to 3,200 years BP. Our work started in Taiwan, including a Neolithic site named Chaolaiqiao, located at the Dulan Belt of eastern Taiwan. This site is dated from 4,200 to 4,000 years ago. Additionally, we were involved in a new excavation at the 𝘊𝘗𝘬𝘋, the botanic garden site in Taipei of northern Taiwan, dated to around 4,600 years BP. In the Philippines, we work at the 2 sites in the lower Cagayan River in northern Luzon. These 2 sites are Nasabrand and Magapit, dated to as early as 4,000 years BP. At Nasabrand, we find identical potteries like those found in eastern Taiwan. Other Neolithic culture elements, including Taiwan nephrite ornaments, Taiwan jet, that can be traced back to eastern Taiwan. Thanks to the support of our Indonesian colleagues, especially Professor Truman, Adi, and Budianto, who we can identify the dating and the rice remains from Minangkabau in Sulawesi. This site is known as the earliest Neolithic site with the remain of a domestic right in Indonesia. Both Professor Truman and Dr. Anggrani have worked here. It is dated to at least 3,500 years ago. The pottery remain and other artifacts from this site are very similar to those that appear earlier in northern Luzon and in Taiwan. And overall, we can reconstruct the dispersal route from southern China to mainland Southeast Asia and the island Southeast Asia through the archaeological evidence. The early farmers brought their rice, millet, domestic animal, such as pigs, and pottery making technologies to island Southeast Asia. They departed from coastal southern China around 4,000 to around 5,000 to 4,800 years ago, and then they reached Taiwan about 4,800 to 4,600 years ago. The northern Philippines around 4,000 years ago, and then Sulawesi about 3,500 years ago. Meanwhile, another parallel and complicated story involved separate dispersal from north to south, occurring in mainland Southeast Asia. Beyond the domestic crop, we are also very interested in the food of hunter-gatherers group. Our recent work in southern China and northern Vietnam discovered that sago, taro, yams, Canarian nuts, and other plants are quite crucial to the pre-Neolithic hunter-gatherers. For example, at a site in Guangdong of coastal southern China, dated to about 5,300 years ago, our colleague, Dr. Yang Xiaoyan and her team found that sago palm was the staple food for the ancient coastal hunter-gatherers. Our recent work in Ha Long Bay in northern Vietnam confirmed that taro, yam, and acorn were the primary food supplies before rice and needed cultivation. Hopefully, we can investigate this question in more detail soon in other regions, such as island Southeast Asia, especially in Indonesia. Next, my colleague, Dr. Deng Zhenhua, will report the details of the ancient rice and millet finding from archaeobotanic study at several sites. So I will stop my screen share.
Okay, I will continue with the presentation. Firstly, I want to thank Dr. Hsiao-chun and Professor Truman for organizing this talk show, and let me have this chance to share our new discoveries and research programs here. So before moving to the new discoveries, I want to give a very brief introduction about the main evidence we used in these studies. In archaeological records, we can get various remains of rice. So here you can see these remains can be divided into two categories, the big ones and the very tiny ones. About the macro remains, we usually can find the rice grains and rice husks. Normally these are the fragments like this one, it's the top of the husk. And the rice speckled bases, this part. And even the embryo, this part of the grain, it will be isolated from the whole grain and other fragments of the grains. Within all these remains, the speckled base, this part is most important as we can distinguish domesticated rice and wild rice according to the morphological features of this part. Most domesticated rice speckled bases are like this one, and the wild ones are normally like this. And about the tiny remains, the micro remains, the most useful evidence in phytoliths. So for rice, there are three typical rice phytoliths, including bulliform, double-peaked, and parallel bilobate. This one and this one is normally from the rice leaves and the stems, and this one, the double-peaked one, is from the husks. So based on the number of the scales, this part there are normally some scales. Based on the number of the scales on the edge of bulliform phytoliths, we can also distinguish this domesticated and wild rice too, as the proportion of bulliform phytoliths with none or more scales on this part are significantly higher in domesticated species than wild. So this is the domesticated proportion, and this is the wild. They are significantly different. About millets, besides of seeds and phytolysis, another useful evidence in the stable isotope analysis from human bones or some domesticated animals. As different from the C3 plants like rice and other common wild plants, millets are C4 food. So when people eat more millets, they will get a relatively higher value of delta carbon 13. So you can see here, people with pure C4 plant like millets, their delta 13 carbon 13 value will be around this range. By contrast, if they eat pure rice or pure other wild resources, pure or wild plants, their value will be in this range. So this the stable isotope analysis is another very effective method to identify the consumption of millets in archaeological research. So now we can continue with the new discoveries from Taiwan, Luzon, and Sulawesi in recent years. The first example is from northern Taiwan, the Zhuwuyuan site. It's in this part, the very northern part of Taiwan Island. We collected more than 300 samples from this site, and the early to middle Neolithic samples yield large amounts of plant remains, especially rice, different types of rice remains, and foxtail millet. This is the mature one, and this is the immature one. Direct radiocarbon dating of these remains confirmed that they can be dated back to at least 4,500 BP, 4,500 years ago. Measurements of all intact rice grains suggest they are very short-grained japonica rice, similar with these discoveries from the Middle Yangtze Valley. So overall, it's the first time we got direct dated Neolithic crops in Taiwan, and the results emphasize the importance of rice and millets. Especially the discovery of millets is very important. This result is similar with the previous discovery from the Nanguan Lidong site that is very famous in this part, the southwest part of Taiwan. They also got rice and millets, foxtail millet and broomcorn millet, dating back to the early to middle Neolithic period of Taiwan. But it's a pity that they didn't directly dated these crop remains. So the next example is from the eastern part of Taiwan Island here. Dr. Hung has just mentioned, here we found the Chaolaiqiao site. Here we found typical red-slipped pottery, and this region is thought to be the possible direct homeland of Austronesian people moving into northern Luzon. As it was excavated in 2005, we didn't got many soil samples, so we can't do flotation here, but we tried phytolith analysis. Here you can see in the 4 samples of Neolithic period, we got very rich rice-bulliform phytoliths. These are the rice-bulliform phytoliths of this type. Besides, we also got other types like the parallel bilobic and double-peaked phytoliths from the rice husks. More detailed analysis of the scales, I mentioned before, the number of the scales on the edge of the bulliform phytoliths, we can confirm that these rice remains from the Chaolaiqiao site are fully domesticated. So now we can confirm agriculture has spread all over the Taiwan Island, at least around before 4,000 years ago, both in the western coast and the east. In addition, current available stable isotope analysis data from Taiwan also demonstrate that millets contributed a large portion of food supplies in Neolithic and Iron Age of Taiwan. So here you can see all these stable isotope data from Taiwan Island. The red ones are all Neolithic, and the blue ones are Iron Age. So these people, this dot you can see here, show a typical feature of mixed dietary of C3 and C4 food. For plants, there are rice, the mix of rice and millets. So out of Taiwan, we got another new discovery from the northern Luzon from two sites. The first site is the Magapit site. Here we excavated this site in 2015. We collected a large amount of flotation samples from this site, and these samples yielded 4 charred rice grains and 1 speckled base. So this is the intact rice grain, and this is one of the only one speckled base we got in this from this site. This is the domestic type. And we also directed one of the rice grains, and it's dated to around 3,200 years ago. It's a pity that we didn't reach the bottom of this excavation square because we don't have enough time. So if we can go back in the future, it's very possible we can get more earlier evidence of crops, rice remains, or even other crops from this site. And another site, the Nagasa site, we also collect large quantities of soil samples. The Neolithic deposit produced 79 rice grains and fragments and 222 drop steers. So this is the rice grain, and this is drop steers grain. And in the Iron Age, from the Iron Age samples, we got 22 rice grains and 4 foxtail millet grains. So this is the Iron Age foxtail millet. We also directed these crops, both the rice, drop steers and the drop steers. So you can see here, these remains could be dated back to around 2800 BP. And the Iron Age starts after 1900 BP. Also, it's a pity that we didn't get earlier deposits of this site, because you may know that in the previous excavations with other researchers and Hsiao-chun got more earlier deposits and artifacts and domesticated pigs from this site that's dated back to 4,000 years ago. So it's also possible if we can go back again, we might get a more earlier evidence of crops from these two sites. Okay, the last example is from Sulawesi. I think everyone here must be very familiar with this site, the Minaga Sipako site in Sulawesi. In 2017, Professor Truman and Dr. Hung and other colleagues went to this site and collected soil samples from the profile of the previous excavation square of this site. Meanwhile, we also picked 5 charcoal samples for radiocarbon dating from these soil samples. So here you can see the result. Samples from the lower layer of this site produced large quantities of rice phytoliths. So the first 3 ones are all rice phytoliths. This is the double peaked type from the rice husks, and this one is the bulliform type from the rice leaves and stems. And this is the parallel bilobate type, also from the leaves and stems. So according to the assemblage of these phytoliths, we can confirm that these remains are closely related to rice dehusking activities at the site, as the proportion of the double-peaked phytoliths from rice husks are very high. So there should be some on-site dehusking activities and in this area actually. So if we can do flotation at this site in the future, we might also get similar results as the 𝘊𝘗 site in northern Taiwan I mentioned before. We might get very similar remains like very rich rice speckled bases and grains. Also, analysis of the scales on the edge of the bulliform phytoliths, we again confirmed that these rice remains from Minaga Sipako also fully domesticated. So for the first time, we got very solid evidence of Neolithic rice remains and on-site rice processing activities in Sulawesi. So that's all these new discoveries and examples I want to share today. And now I want to give a very brief introduction, conclusion, and finish this presentation. Firstly, I want to say in the past few years, we have got more and more evidence to support the farming language disposal model of Austronesian people. Agriculture disposed from the southeast coast of mainland China to Taiwan and then Luzon and then other parts of the island Southeast Asia. Synchronized with the migration of Austronesian people. Secondly, different from the previous hypothesis of pure rice, early Austronesians possibly cultivated rice and millets together. The importance of millets have been overlooked in the past, and more attention is needed in the future studies. So here I also want to see, hopefully we can get more chance to explore this question in collaboration with everyone here. Maybe we can get more collaboration and targeted work in Indonesia in the future. So thank you very much for your attention, and yeah, thank you. I'm finished.
Okay, thank you very much to Dr. Hsiao-chun Hung and Dr. Zhenhua-Deng for giving us such an informative and interesting presentation. I invite all of you, if there is any question for those who on Zoom or on the YouTube, you can ask question in Indonesia or in English, or please write in the chat column or use the raise hand feature. Okay, the first question is from Mr. 𝘗𝘗𝘈𝘆 in the chat. He wants us about your presentation is. I want to ask if there is a difference between wild rice and domesticated rice.
So I will answer this question. Actually, until the beginning of my presentation, I gave a very brief introduction of this question. There are many differences between wild and domesticated rice, but now the most reliable criteria to distinguish these two, the wild and the domesticated rice, we got two very effective or reliable criteria. The first is the morphological features of the rice speckled bases. So most of the domesticated rice show a non-shattering trait, so the seed will not drop after they enter matured. Where the wild rice, most of the wild rice are show a shattering trait. The other is from the other criteria is based on the phytoliths, the bulliform phytoliths from rice leaves. The the proportion of rice bulliform phytoliths with none or more scales on the edge of the bulliform phytoliths is much higher in domesticated rice than wild. So you can see at 𝘊𝘗 and Minanga Sipaco, we use this criteria to distinguish domesticated and wild. Yeah.
Okay, thank you for the Prasejarah. Okay, and there is Miss Anggraini, please. I think she is an archaeologist from UGM, please.
Okay, thank you very much. I'd like to ask more about the distributions of millet and also ☚ Are they, do they have a similar distribution compared to rice? Thank you.
Xiao-chun, you want to answer or me?
Your question is for China or from China to Indonesia?
Yeah, anywhere. Because I'm curious about the distribution of millet and also ☚ Do they have also distributed in Indonesia or just in China or in Taiwan? Okay, thank you.
I can present my thought first, and then maybe Zhenhua can provide a very detailed chronology about this from China. I am so interested of this question that Anggraini just asked. Do you have a very ancient millet and jobs here in Indonesia? Personally, I believe you have in Indonesia, and very probably as early as rice. Maybe can be traced back to more than 3,000 years ago. Like in Sabran site, we actually found both three, rice, millet, and jobs tea. And there are several, also in Taiwan. In Taiwan, there are like the Nanguanli Dong site, you might already know, in southwest of Taiwan. They actually also found this three type of crop. Yeah, so this is waiting for you to investigate in the future. I feel this is a very important, very interesting question.
Yes.
And Dr. Deng, Zhenhua, do you want to add more detail of the distribution in China?
Maybe I can share the screen again and show you the map we used in the PowerPoint.
Okay.
So here you can see, although it's not that large, but we can use this part. When we talking about millets in East Asia or even East Asia and Southeast Asia, we mainly talk about two types: the foxtail millet and the broomcorn millet, or the common, or we call that the common millet. These two are all domesticated in northern China, out of this map, much to the north of this part. But around at least around 5,000 BP, 5,000 years ago, these two types already dispersed into southern China, in these regions, and also here. So makes the pattern of both rice and millets has formed at least before 5,000 years ago in southern China. And then this package, the package includes rice and the two types of millets, moved southward into other parts, into mainland Southeast Asia and Taiwan and island Southeast, I think. So about the current evidence, most parts of southern China we have got solid evidence of both rice and millets. Like you can see, these sites all got rice and millets together. And also in mainland Southeast Asia, we also got some clues that millets possibly emerged together with rice, like in southern Thailand. They got fox millet dating back to earlier than 4,000 years ago. So it's very possible millets dispersed into this patch along with rice. Taiwan is also the same, but we are not very clear about this patch, the island patch. As I mentioned before, in Antanagsabaran, we got two different types of millet, the dropsteers and the fox millet. The dropsteers is very much earlier, and the fox millet is later, emerged around 1,900 BP. So we're not sure rice and fox millet come together or separately. It's a question needed to be explored in the future. But another question is, where did these dropsteers come from? To be honest, it's not very clear now, as we know very little about the domestication of dropsteers. It's believed to be domesticated in subtropical or tropical regions like southern China or even Southeast Asia. In archaeological records, we got some early evidence. One evidence is from the southeast coast of China, in the Fujian province, almost here, I think. One side we got dropsteer grains dating back to 4,500 BP, I think. And in Taiwan, they also got dropsteers, but it's much earlier, much later, I think. It's not in Neolithic sites. We didn't got direct evidence. And Nagsabaran, we got these dropsteers dating back to 2,800 BP. And another discovery is from mainland Southeast Asia. It's here, I think, around this region. It's unpublished, but we can confirm around 4,000 BP dropsteers had emerged in mainland Southeast Asia also. So it's quite possible that this package also dispersed into other parts of island Southeast Asia, but we need to do more targeted work in the future to confirm whether they come together or separately.
Thank you so much.
Okay. Thank you, Ms. Anggraini and Professor Hung. The next question is from Ms. Khalifa. Okay, I will translate in English. She has two questions. The first is, for the phytolith Musa sp, is there any difference between the shape and size of wild and planted Musa sp? And the second question, it has been mentioned previously that the findings obtained are seeds, phytoliths, and isotopes. What about the finding of starch grains? Okay.
Maybe Zhenhua, you can share your screen again, the one with the phytoliths, so you can answer a question about how to identify. Your first, I think it's in your first slide.
Yeah, I will share it again. So you mean this one? Or the phytoliths of the
yes, the phytoliths, yes.
So what's that question actually? What's
the identification of domestic or not?
You mean rice?
I guess. Could you repeat the question?
Because that's in.
Okay, the first question. Yeah, the first question is about Musa sp, banana. For the
Yes.
phytolith banana, is there any difference? Yeah, between the shape and size of wild and planted banana?
Oh, about banana.
This one. The phytolith of the Musa type is not. I think we can't distinguish the domestic and the wild very effectively. We can only see it's the Musa type. Yeah. And actually, we only got one suspected species from the Naga page, because the preservation condition of phytolith at this site is very poor, and we continue got typical rice phytolith remains. So that's the only one discovery of the Musa. We can't see whether it's domesticated or wild. We can't. And the second question.
And the second question is it has been mentioned previously that the findings of these are seeds, phytoliths, and isotopes. What about the findings of starch grades?
Starch. Personally, I didn't do starch grain analysis. Maybe Hsiao-chun can see more about their new work in the mainland island, Southeast Asia.
Yeah, I present two examples. One is from Guangdong, another one from Halong Bay area. That was the basic starch study. Actually, combine starch and the phytolith together. Yeah. That was the older collection, older excavating material by Vietnamese colleague. And then we went to storage, wash the stone tool, recollect the sample and analyze what remain on the stone tool. And basically that is a pre-Neolithic site dated to more than 5,000 years old. Then we found many different types of food they consume in their time, including taro, yams, acorn, and another one is very interesting is the edible fern, the root of a fern.
Thank you for the answer.
Thank you.
And yes,
Mbak Devi, boleh. Yeah, thank you, Siswa and Sanchua for your answer. Mbak Devi, mohon izin untuk ditranslate ya. Saya ingin menyampaikan sedikit informasi barangkali untuk bahan diskusi. Jadi di satu situs di Pulau Kangean, waktu kita melakukan penelitian juga ditemukan phytolith Musa, tapi dengan konteks kronologi 6.000 BP. Jadi jika disampaikan bahwa Austronesia datang sesuai tadi yang dipresentasikan dengan konteks kronologi yang sebelum 6.000 BP, dan salah satunya adalah pisang, ini mungkin menjadi bahan diskusi ketika di satu situs di Pulau Kangean ditemukan juga indikasi pisang yang pertanggalannya sebelum kedatangan Austronesia. Jadi ini mungkin sangat penting untuk tahu bagaimana perbedaan antara phytolith pisang yang liar maupun yang didomestikasi. Mungkin itu sedikit informasi untuk bahan diskusi bersama. Terima kasih banyak Mbak Devi.
Okay. So Miss from
Mbak Alifa.
Miss Alifa, yeah. Okay. Professor Alifa, she want add some information about that she found Musa phytolith with a context of 6,000 BP in Kangean Island. Yeah, so she invited that it is so interesting topic that it will be good if there is if it will be a next discussion about Musa. Maybe Mr. Ruli can add some.
Maybe the right question. I will try to formulate the question. It's about Mrs. Alifa asking about the antiquity of Musa, of a banana domestication, I think, or at least maybe not really domestication, but utilization in our prehistory. How about what do you think about that? When did human try to consume the banana in the antiquity of Southeast Asia and mainland Asia? Do you have any idea on that question about the antiquity of Musa or banana consumption within the prehistoric community, both in mainland and Southeast Asia? Because apparently, Mrs. Alifa found that there is an indication of the appearance of phytolith of banana from one small island on the north of Bali in Kangean Island. It's a cave site and really well preserved, and they found several evidence of appearance of phytolith from banana. Please, Dr. Hsiao-chun and Dr. Zheng, you have any idea?
A little explanation. So,
Okay.
So far, archaeological data about the banana domestication came from Papua New Guinea, PNG, dated to around 6,000 years BP. Now, the same as the banana found in Kangean Island, from around 6,000 BP. The question now, whether this banana is domesticated plant or wild plant, or if it is domesticated, who domesticated this plant? Of course, I am very sure not Austronesian, nor Austroasiatic. It is possible the Australo-Melanesoid people, but I don't think so. So in my view, it is possible that this banana is wild, not domestication. Yeah, just a short comments. So please, the two distinguished scholars maybe can explain, give some more explanation about this find.
Okay, I will say. Actually, I'm not very familiar with the domestication of Musa because most of my studies are focused on these domesticated crops like cereal crops. As I can recall, according to current evidence, as that Professor Truman said, the earliest evidence, most of the earlier evidence are from Papua New Guinea or the near other islands nearby. So many researchers, I think, they tend to believe this Musa was domesticated by these indigenous populations instead of the Austronesian people, and the domestication might be very early, possibly 6,000 BP or something like that. But to be honest, I'm not very familiar with these new progresses and the details of this study.
I hesitate to make any comment for this question. I'm not familiar with banana domestication, but my memory, what I remember from past reading is very similar to what Zhenhua just said. And actually, in our work in northern Vietnam at the pre-Neolithic site, we also found phytoliths of a banana from the pre-Neolithic site, and probably dated to older than 5,000 years old. So where is the origin of the domestication for banana? I'm not sure. Yeah. But this is a very interesting question to investigate.
Yeah, it's about the origin is still in debate, I think.
Yes,
some
because
scholars,
it's a debate.
Yeah, the origin is from the east, from Papua New Guinea, and the other one, thought that this kind of plant came from mainland Asia. Still
Yes,
clear.
It's very similar to taro.
Yeah.
It's also, although many people believe the domestication center is in Papua New Guinea, but there are some genetic study and other new findings actually suggest the mainland is the origin of taro domestication.
Yeah.
So, but this is all like appear much earlier than the Neolithic migration. This is all much earlier.
Ibu Mahirta, barangkali ada yang bisa disampaikan, Prof. Saya lihat di chat.
Saya di sekitar ruang yang sangat ramai. As far as I know, there are two types of bananas, but I myself do not have knowledge the difference of the morphology of two types of bananas. Yeah, that the one that originate from Papua and the other originate from island Southeast Asia, but mostly originate from Papua. Yeah? There are also two types banana that go rise, not the fruit is not going down, but going up. Yeah. So it is our challenge to study about the banana in island Southeast Asia, I think.
Yeah. Yes.
We try to find together. Thank you. I can remember I think there is a guy from, he's expert in banana. Kennedy, the name.
Oh, Jane Kennedy.
Kennedy, yeah, Jane
Yes.
Kennedy. Hsiao-chun know her.
Yeah.
Thank you.
Thank you, Ms. Mahirta. And the next question is from Mr. 𝘗𝘀𝘀. As far as I know, rice is now grown in both wet and dry land. Ancient rice from Taiwan, Philippines, and Minangkabau Paco, which type? Dry or wet type?
Okay, I will take this one. Yes, we got both different types, the wet rice and the dry upland or the dry rice nowadays in Taiwan, southern China, or island Southeast Asia. It's very important to distinguish whether the ancient ones are wet or dry. But to be honest, I don't think Norway we got a very reliable method to answer this question. There are some scholars tried different methods. For example, the assemblage of weights, the farmland weights, the assembly of the weights to speculate whether the ancient rice was dry or wet. Or some others tried the assemblage of phytoliths. There are two different set of methods, but I don't think these methods are effective or reliable actually, because normally the assemblage of weights or fatalities we recovered from the archaeological sites are a mixture of different sources, like from some of them should be come to the site together with crops, with rice, but others may be from other sources, from other activities. So that makes the record can't be used to speculate the growing environmental or growing environmental of rice. So I don't think we can answer this question now, but it's really a very important question we should explore in the future. Yeah.
Okay, thank you. And Mr. Wibisono asked, if not mistaken, in Sireh cave, rice husks were also found. Have you studied it?
Sorry, I didn't hear it clearly. Can you repeat it?
Okay. In Sireh cave, rice husks were also found. Have you studied it?
Oh no, we got. I know that the 꽌ᴨ, yeah, we didn't got these samples. Maybe hopefully we can.
Yeah, that one was excavated by Professor Peter Bellwood in 1970s or 1980s, long time ago, and about 3 or 4 years ago, some researcher, including Professor Peter Bellwood himself, they actually reanalyzed this sample, and the new result is turned out is since the rice from 꽌ᴨ is not as early as previous suggest. Previously suggest it's like 4,500 or 4,800 years BP, but the new date they have now is only, it's Iron Age. It's like 2,100 years BP. So they actually, change the story for 꽌ᴨ rice. But we have not worked on this collation.
Okay, thank you. And this is there are questions from YouTube. We can check in the chat box. Is there any significant changes on the microorganic remains of rice and foxtail millet due to human activities such as intensive seed breeding? Is it possible to identify or trace the difference between ancient rice remains grew in the mainland and Southeast Asia in order to reconstruct its origin to corroborate the result of its chronological distribution?
I'm afraid we can't get evidence for these macroorganic remains. It's difficult, I think, to get evidence for these questions. Yeah, it's because most of the organic part can't be well preserved in archaeological records, so it's difficult to investigate these details, I think. Yeah.
Thank you. Okay. Is there any more questions or sharing about this topic? I think no more questions, right? Because it's so clearly explanation. And I think this topic is so interesting, yeah, because honestly, I have no idea about the rice, but thank you for the presentation. I learned something now about the rice, yeah. We finally come to the end of this talk show. Before close the talk show, maybe from the Dr. Zhenhua-Deng and Hsiao-chun Hung want to say something about the conclusion
You first.
Thank you, everyone. I enjoyed the discussion very much. We are very happy to receive many questions. Many of the questions we don't have an answer for now, but this is good. Many questions are waiting for all of us to investigate in the soon future. Thank you, everyone.
So also, I want to thank everyone participating in this talk show, and it's very happy to got this chance to share our new discoveries in the recent years. And as you can see, the island of Southeast Asia region, including Indonesia, we have many more questions to explore in the future, and hopefully we can get more chance to collaborate with everyone here in the future to explore this question in Indonesia. Yeah.
Thank you.
Thank you very much.
Thank you to Mr. Sun for sharing and Ms. Hsiao-chun Hung. And now I please to Prof. Roman say the conclusion.
Oke, bukan main ya, diskusinya begitu hangat ya, dan tentu menambah pemahaman kita. So our discussion this evening, in the camera is already evening now, but here is still afternoon. That's okay. So it's very, very interesting. Yeah. So we are very enlightened about the origin and the spread of rice and millet cultivation in a very vast area, yeah, including Indonesia. And we know from the presentation, yeah, that rice and millet have been cultivated since around 8,000 years ago, yeah, in southern China, in Yangtze Valley, yeah, and from here this plant spread along with the expansion of Austronesia to other region. It's very interesting. So melalui data domestikasi awal padi ini, ya semakin jelas rute persebaran manusia di masa lampau, ya, terutama di Austronesian. Ya, so from the rice cultivation data, ya, gives supports for the out of Taiwan migration, ya, the out of Taiwan theory. Ya. The problem now, actually in Indonesia, data on early rice cultivation is still very, very limited. Sangat-sangat jarang data tentang padi yang kita miliki sampai saat ini. And Hsiao-chun and Zhenhua just talked about that the oldest date so far only comes from the Minangkabau sites in Sulawesi. That is from around 3,500 years ago. Yeah. And I'm in my view, there could be, yeah, some slightly older than 3,500 years the presence of rice in Indonesia, judging from the arrival of the Austronesian, which is older than 3,500 years maybe. Yeah. And my question also to myself is the presence of rice, yeah, in the western part of Indonesia. Yeah. Just to remind you that the spread of Neolithic culture with its domestication characteristic most probably come from two directions into Indonesia. Firstly, from mainland Southeast Asia, brought by the Austro-Asiatic speaking people. And I call this the Western route migration. Secondly, from Taiwan, by passing the Philippines, entered Indonesia by the Austronesians. Yeah, this is the eastern route migration, and both, if we trace further, yeah, came from southern China, from Yangtze Basin or valley. Yeah, so in my view, besides being brought by the Austronesians, rice could be also brought by the Austroasiatic in their migration to Indonesia. The problem, and this is the challenge for us, yeah, that up to now, early rice domestication in the western part of Indonesia is still very, very rare, if not say absent. Yeah. So those still unanswered questions are the big challenge for future research, including its development over time until now. So hopefully this talk show or discussion will be a trigger for researchers or students to be interested in doing studies on the origin and distribution of rice and other plant domestication in Indonesia. More plant domestication studies in the future will certainly give a better understanding of the history of our nowadays staple foods, and also more or better understanding on the origin of the Indonesian people. Yeah. So yes, I'm so very, very happy for this discussion. So again, I wish to thank Dr. Hsiao-chun and Dr. Zhenhua, and also Devo, and all participants, especially those who have already gave comments or ask questions. Thank you for all. And this is a good news that we are still very interested in rice domestication. And now we have to start a new model of research. We have to accelerate research on the domestication in Indonesia, hopefully in the near future. Thank you very much. So if you give the time to Devo.
Thank you very much to Prof. Truman. And before we close this talk show, I'd like to thank you to the speaker, to Dr. Hsiao-chun Hung and Dr. Zhenhua-Deng for the informative and interesting presentation, and all the participants for their very active participation. And thank you very much for.
Thank you.
Thank you very much, Dr. Zhenhua and Dr. Hsiao-chun.
Thank you, everyone. I'm very happy to
Thank you
see
all.
many of you. I know many names. I already know.
Thank
like
you
Rudy.
very much for the
Thank you very
All
much.
the friends.
Oh.
Thank you. So happy to see all of you today.
Yeah.
Hopefully we will have another research in the Karama Valley. And what about the Karama Valley now? People in Sulawesi? Because I heard that the government will build a dam there.
Oh, really?
So I hope it will be cancelled.
Anggraeni just visited this area, and she found very interesting data about the what you call that metal object,
like
also human burial in
Early Middle Age settlement.
Middle Age, yeah.
Yes,
Middle Age.
yeah. So I continue my research in Palembang, and I hope, yeah, I need more evidence for sure about the house formation there in the early Middle Age.
Yeah, yeah.
Okay, thank you so much, Hsiao-chun.
Thank you
See
so
you
much.
next time.
See you.
Thank you
Bye
so
bye,
much.
everyone.
Thank you.
Okay, thank you very much.
Thank you, Ruli. Thank you.
Baik, thank you.
Bye.
Terima kasih.
Terima kasih.
Thank you very
Terima
much
kasih.
for our speakers today. Thank you very much for all participants who participated until the end of this talk show. See you in the next episode of Center for Prehistory and Austronesian Public Talk Show. Thank you. Goodbye. Good afternoon.
Bye.
Bye.
Thank you.
Terima kasih Mas Ruli, Pak Truman, dan
Terima
juga
kasih.
dua narasumber. Mohon izin keluar ya.
Pamit Pak Truman.
Ya,
Mas Ruli.
kasih.
And see you in the next IPPA. I hope.
Yeah.
We
Hopefully.
will.
Bye.
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 Bagus juga ya.